Java is a computer language developed in the early 90s by a team led by James Gosling. It was majorly developed for the internet and to provide cross-platform compatibility. One of the major characteristics of Java is that it is platform independent. So what platform independence is basically? Let's go back to our classroom. But this time, apart from the teacher speaking Japanese, each and every student in the class speaks a different language. And nobody knows to speak or understand in any other language. So how is learning possible in such a classroom? Neither can a translator work here, nor a few copies of the translated lecture. Even if we give customized translated lectures to individual students, what about the discussions that happen in a classroom? Those discussions can't be predicted, right? How would teaching and learning be possible then? It is possible through Java's property of platform independence. Let us suppose we distribute a customized headphone microphone set to each and every person in the classroom, including the teacher. Whatever the teacher speaks in Japanese, the microphone converts it into a language that nobody speaks in the entire world. Let's call it language X. Whereas a student's headphone is designed in a way that converts that language X into the respective language of the student. When the teacher speaks in Japanese, students receive the lecture in their respective languages. This is the basic idea of platform independence. So how has Java's platform independence shaped the world we live in today? In 1991, when the internet went public, the grand vision was to connect every computer in the world with another. But people have different operating systems. How could a program written on one operating system run on another? This is where Java's platform independence came into play. For each operating system, a compiler was designed. That compiler would translate the program into bytecode for a virtual machine called Java Virtual Machine. That bytecode is basically language X. Now to run that bytecode on multiple platforms, an interpreter was designed for every platform. That interpreter would run the bytecode in the respective platform. So basically, now if you had the Java compiler and interpreter for your platform, a program written on your operating system could be compiled and converted into the bytecode. That bytecode could be received by another person and could be run by the interpreter on his platform. Therefore, a program written on Linux could run on Mac, and a program written on Mac could be run on Windows anywhere in the world, connecting every computer. A thing to note is that Java uses both the translators, compiler and interpreter. Why was a compiler used in the first stage? We know that a compiler converts a program but doesn't execute it. Since we don't need any execution here, a compiler is used. And why was an interpreter used here? Because in this stage we needed to execute the program, and a compiler converts the source code into bytecode, stores it but does not execute it. Since an interpreter executes the machine code, that is all we need. What we have learned so far is necessary to really fall in love with coding. Now that we know how Java's compiler and interpreter works, let us write our first program using Java.